bracket
x squared minus 2 over x
to the power of 4.
bracket
5. All to the power of 5. Okay.
expand and simplify.
Oh, expand and simplify. Okay. Well, it just means do the whole thing.
I know.
Great. You got
I'm
some.
running out of questions, guys. Wait, what?
Right. So this is good because one of the things you're going to have to do is expand and simplify. So we're not looking for just a term. So expand and simplify means do the whole expansion, then collect all your like terms together and make it one thing, you know. If you think about where this came from, we did a plus b to the power of 2. So you had a quadratic and you just did FOIL, and then you collect the middle terms and so on. So something like this is, you've just got more brackets and you have to expand and collect it all together. Pardon? That would be cheating and not allowed in an exam. So should we? So basically, then, I don't know whether you want to use this. We've got the a term is x squared. The b term is minus 2 over x to the power of 4. Okay. So when we do our expansion, we have 5, 0, and then it's x squared to the power of what? 5. Okay, do it that way. And then we add 5, 1, and we've got x squared to the power of 4, and then we have to multiply by minus 2 over x to the power of 4 plus 5, 2 x squared to the power of 3 multiplied by minus 2 over x to the power of 4 squared, and so on.
Wait, what about... Oh, so in the first one, for 5, 0, minus 2 over x4 isn't there?
Well, remember it's to the power of 0,
Oh.
which is 1, so I just don't write it. Okay. So remember all the powers add up to 5 every time, so 4 and 1, 5, 3 and 2, and so on.
Is the minus for only the 2?
Well, if you put a minus on top of a fraction, the whole fraction is a negative, isn't it? Okay. We could put the minus in front of the whole thing, but just for ease of writing it, I've just made it. If, for instance, like we've talked about before, you've got minus 1 over 2, or 1 over minus 2, or minus 1 over 2. They're all minus a half, aren't they? Okay. So that's what I've done. But we have to remember that the minus goes with that second term. So what have we got then? 5, 3 x squared times minus 2 over 3 plus 5, 4 x squared to the power of 1 times minus 2. And finally 5, 5, and then it's just minus 2 over x to the power of 4 to the power of 5.
So they never give us like a really huge number for expanding.
Oh no, you'd just be there for ages, wouldn't you? If you had to do every term of to the power of 20, you'd be, unless it was one where you had to spot that all the terms were 1 or something like that. Yeah. So let's do it in parts then. So 5, 0 is, so I've got 1 times x to the power of 10 plus 5, 1 is 5, and then we've got x to the power of 8, then we've got to multiply by minus 2, and it's all over x to the power of 4, which you can see is going to simplify. I'm not going to do it yet, I'm just going to keep it organised, just do it step by step so I don't lose track of where I am, so I'm just writing these out.
That's 5 times x to the 8.
So that bit's 5, that bit's x to the power of 8, and then we've got minus 2 to the power of 1 all over x to the power of 4. Because when you're multiplying everything and then you've got a division, you do the whole thing. The next one then, 5 to 10. So 10 times x to the power of 6, and then it's times 4 all over x to the power of 8. So those ones done. And then, so I know that's 1, 5, 10. So I've got x to the power of 4 minus 2 cubed. Negative 8 all over x to the power of 4 plus 5x squared times minus 2 to the power of 4 is 16. Oh, sorry, I've got something wrong there. That shouldn't be 4, should it? See, that's what happens when you've got to check your work. That should be 12, yeah. And then finally, 1 times minus 2 to the power of 5 is negative 32, and that's all over x to the power of 20. Now simplify. So,
This takes so long.
yeah. So let's simplify these. So that would be gone. So this would become a 4. This would be gone. That would make a 2. This would be gone. That would become an 8. This would be gone. That would become a 14. We've got that. Say again. Remember, we don't divide the powers, we subtract. That's what someone was saying. Right. How you feeling about this one so far? A lot of work, but not so difficult yet. No?
Wait, for number turn 3, why is it just x to 2?
For this one,
Yeah.
because I've got 6 x to the power of 6 on top and x to the power of 8 on the bottom, so 6 of these cancel with those.
But wouldn't that be a 3 on the top? X to the power of 3?
Now remember, when we divide with numbers raised to powers, we subtract the powers. So 6 of them on the top, and I've got 8 of them on the bottom. So the 6 on the top cancel with 6 on the bottom, so I'm only left with 2 of them. Do you remember your laws of indices, which is like a to the power of m over a to the power of n is a to the power of m minus n. So that's what I'm using. So what have we got then? We've got x to the power of
Oh, I missed that.
10.
I'm so lost.
We've got plus how many? So actually that's a minus 10 x to the power of 4. Right. And then we've got plus 40 over x squared. And then we've got another minus 80 over x to the power of 8 plus 5 times 16, 80 x to the power of 14, and then minus 32 over x to the power of 20. Now, I don't know, do they want to simplify further than that? Yeah. So, what do you do when you add and subtract fractions?
Make the like denominator.
So the denominators have to be the same. Yeah? So, what denominator should we? So all of these we're going to multiply by an x to the power of something, aren't we? Yeah? So we'll probably get them all to x to the power of 20. So x to the power of 10 needs to be x to the power of 30 over x to the power of 20. Are you okay with that one? Then minus, we've still got the 10, but then to get it x to the power of 20 again, I've got to multiply, so that means that's going to be x to the power of 24. Happy with that?
Wait, what are you timing?
Well, I'm timesing, both of these had to have x to the power of 20 on the bottom. I want to get to this one.
Okay.
So remember, to find an equivalent fraction, you multiply the top and the bottom by the same. So if I consider that to be over 1 and that to be over 1, if I multiply by x to the power of 20 to get what I want, I also have to do that on top. And you do that, you add the powers. So the same with this one, I had to multiply by x to the power of 20, therefore x to the power of 20 there, which add the powers. But the next one, x to the power of, sorry? 18. Okay, so that gives me x to the power of 20 and then 40 x to the power of 18. This one would be minus 80. How do I get from 8 to 20? So it's x to the power of 12. And then minus 32 over.
Yeah.
Oh, yeah, I thought I had. Plus 80 x to the power of 6. And then minus 32 over x to the power of 20. Do we look like we're going the right way?
Yeah.
Courtney's got.
You should have x to the power of 8 as your first one.
This should be x to the power of 8.
Yeah.
What?
Rattled. And then for the last word, our fraction.
Oh no, we haven't finished yet, so let's. You're looking at the final answer, or are you showing the work now? Okay.
Wait.
I'm sorry, we don't have work yet. It's just final answer.
Wait, so do you put like, do you put them on the line?
So now we've got x to the power of 30 minus 10, x to the power of 24 plus 40 x to the 18.
So, if I got this question in an exam, I just need 20 minutes.
Right, well, this type of question is not going to come up in your exam.
It's thickness 13, 14.
It's a challenge question. You find it on things like that online. They're not the kind of questions that are used in an
Is
exam.
this like a higher level question?
Potentially.
Okay.
Yeah.
I think, yeah, it's not that bad. It's just a lot of.
Yeah.
Carly looked at me when I told her to expand this inflection. She was like, "That's easy."
Oh, it was supposed to be easy.
It's easy, but it's long.
Yeah. I mean, it's not hard. The maths is not hard.
Okay, take it down a level.
Okay, so maybe it's color coded.
In what way?
Extra.
Carly, how can you not understand that? It's pretty
Because
simple.
don't you gotta simplify the terms?
We can simplify.
You're sure?
He didn't simplify it. All he did was remove
I
each
know,
individual
that's
one.
what I said.
Well, because you have a 32 and the 32 doesn't have an x.
Yeah. So we couldn't factorize
I don't know how to do that.
Well, yeah.
I suck. I would have thought I got it.
So what answer have they got? Oh, so they didn't do what we've just done.
It's okay. What we just did is still correct, right?
Yeah.
Will we ever get binomial extension questions with surds?
There was one
Yeah.
on the,
Because there's one
on
of
the
the
common
Pogby, and Miss Melody asked me yesterday.
With the X?
And we've done them, and I said we've done like one or two, but
I haven't
It was
done
an
that.
X.
Just before we move, so we haven't kind of got agreed with their answer, but the process of
we will.
doing it and expanding it, is that kind of okay for you?
Yeah.
We're not going to have to get to the one like this. Is there anywhere that we've kind
So
of
please ask to expand and simplify. You just find what each one equals, and then
all of them and then add them together? Yeah.
And you have to simplify it, or
Well, expand and simplify, yeah. But you'll get one that's easier than that. So, for instance, let's have a quick look. Now, you'll go, I think we did one. So let's just say we've got something like 3
I can
plus...
give you all of the parts.
Wait, Mr. Pops,
All right.
finish with our last question?
Yeah, well, we're going as far as we need to go.
Do you want like an easy one or like a semi-hard one?
Well, I was just going to make some numbers up. Have you got a specific one? Go on.
Okay, the third 7,
Root 7.
root 7, bracket, -5, plus root 5. No,
Wait.
that one's not negative.
Yeah, it was just a slip of the pen, that's all. Not to the power.
Doesn't have one.
So then it's not
Okay, right. So this is not a binomial expansion question.
Oh, I've got one.
This is...
It says it is!
But this is just an expansion, so this would be -5 root 7 plus root 7 times root 5, which would be minus root 7 plus root 35.
Can we?
Now, what you try and do is you try and split the radical here to get a square number, but 35 does not have a square number as a factor. No? 7 and 5, both primes. What we could have done is factorised it, but that's what we're started with. Now, if you did something, so a different question, let me just make something up off the top of my head. If I said, so 3 plus root 2 to the power of, let's do to the power of 3. So now if I had to do that,
That's a binomial expansion.
this could be a binomial expansion because I've got by, like 2, right? 2 parts within the brackets. I've given a very small expansion. You could do this just as 3 plus root 2 times 3 plus root 2 times 3 plus root 2. You could do it just like that if you wanted to. Expand the 2 brackets and then do it final. That's one way of doing it. Or we could do binomial expansion, which would be 3, 0, 3 to the power of 3, plus 3, 1, 3 squared times root 2, plus 3, 2, which would then be 3 times root 2 squared. This is why it could be a third one as part of an expansion, because checking your knowledge here, and then also finally 3, 3 root 2 to the power of 3. Now I could ask you to leave it in third form. So I've expanded, now I need to simplify. So that is 1 times 3 cubed, so that's 27, plus 3 times 9 times root 2, so that's 27 root 2. Okay. This is also 3, so I've got 3 times 3 times what's root 2 squared?
2.
2. So I've got plus 18. And then finally it's 1, so I've got 1 times root 2 cubed. Now how would you do that? 2 root 2, good. So that's 2 root 2. So I've got plus 2 root 2.
Wait, how did you get 2 root 2?
Because root 2 cubed is root 2 times root 2 times root 2. And you take the root 2 times root 2 and just make it as 2 in the same way that root 2 squared was 2. So now we just collect it. 27 add 18 is 45 plus 29 root 2. So that's how I can do one with a surdine.
Can I look do one with N, like when you don't know what it is? Okay, this one's really hard for me.
But can you look up this one?
Well, don't make it too hard for me to do it. It's period 1. I can just send you this file. Taking photographs. And it's on a video.
Okay.
Okay. Right, what's your bracket?
1 plus kx
Ugh.
No.
to the power of n.
What? 3 unknowns.
But you assume x
N
is
is
known.
positive. It's a positive integer.
N is an element of that.
And x is the positive. N is a positive integer in ascending power of x.
What the?
Say it again.
Okay, so where
N is an
positive integer
yeah.
in ascending power of x is, and then it's 1 minus 36x. It's. Do you want to read the question?
Maybe better.
Or I can just look up the easy one.
Yeah. Maybe we can answer that question.
Oh, where N is positive in ascending power of x is 1 minus 36x plus 594x squared plus. Okay. So that's just being told what the expansion is.
What does
So,
this
right.
even mean?
What that means is they've done the first 3 terms of the expansion. So we're going to use this information to find K and also find N. Alright. So the information we've got. Well, if we did our expansion, these things, we could say that the first one would be n0, which we know is 1, and it would be multiplied by 1 to the power of n, which is going to be 1. So that piece of information does not help me at all. Okay. Does that make sense? Because it'd be 1 times whatever n is, it's going to end up being 1. So there's nothing there. The next term, though, would be n1, okay, which would actually equal n, right? Because we know that, and it's going to be multiplied by 1 to the power of n minus 1, which will still be 1, so that doesn't affect things. But we're also this time be multiplied by kx to the power of 1. They've made it easy. Do you remember we did one of these before where we had to look at it from the other end and go backwards? They've made it nice by saying it's an ascending power of x. They've made it actually an easier one for us to do.
What is that weird letter something?
Here, what?
Saying
That,
that's a positive integer.
yeah. That's what that means, positive integer.
How come you're not adding n0 with n1?
Why am I not doing
Why are you not adding those two? Okay.
I can. I've just kind of. I don't want to. I want to consider them. I'm not actually going to add anything together. I'm just looking at the terms. Now, the thing here is, look, if I consider that term, this then becomes n times kx. Alright? Does that make sense?
Yeah.
And that equals minus 36x.
Wait, but how is it n times kx when you still have the times 1 n to the minus 1?
Because anything to the, when 1 is the base and anything to the power, it's always 1.
Yeah.
Oh, that was
Again, they've made it. You can't really.
anything to
This would be a much more difficult question if we had anything other than 1. If that wasn't a 1, change the question completely.
But you don't know what n is.
We don't yet, no.
So how do you know the answer is 1?
I don't know that n is 1. I know that that's n, but I know the 1 to the power of n minus 1 is always going to be 1. Yeah? This thing here, regardless of what n is, will equal 1.
because 1 to the power of anything is 1.
Yeah, like 1 to the power of 2 is 1.
Yeah, but
1 to the power of a million is 1.
all 1 if it's n minus 1.
Well,
No, it
n
doesn't
minus
have
1
to
is...
be to
It
the
doesn't
power
matter
of
what that
1.
value is.
Whatever, if it's 1 to the power of something.
So what we're saying is we don't know what n is, but we know whatever it is, the answer will be 1. Yeah?
Yeah, that's all.
Right, now we've still got 2 unknowns there. But we've got another term, which would be, this time we've got n2. Right?
How do you know how many under the ends there is?
We don't. It will go, depending on what n is, it will be whatever that is, yeah? But I know it's 0, 1, 2, 3, but I just don't know how long that will go on for. But I am told that this is the first term, this is the second term, this is the third term.
You don't really know if there's another one after it.
No, I don't. But if I was told there wasn't, I'd know it straight away. I'd know n was 2. But this time we've got n2, and then we've got times, again, 1 to the n minus 2.
Isn't that a negative? The second term, wouldn't that be a negative? It's minus 2.
Well, I don't know what n and k are yet, so k, I know, has to be negative. So I know k is a negative number, because n can't be. Right? So there's one clue. I don't know what yet, but... Right. We've got n to the minus 2. Now again, what's the situation with 1 times n to the minus 2? It's going to equal 1 again. Doesn't change it. This time I can't tell you that that is n though, can I? Because it depends what row on the Pascal. It could be anything. How am I going to know what that is equal to?
If you know what K is.
Well, even then, how do we use, this is what you're missing. When the power is unknown, you are going to have to use
Factorial
n factorial stuff, yeah, the formula.
Yeah.
But let's see what we get. And then we've got times k squared x squared. Or if you'd rather, I write it like times kx all squared. Do it like that first. So that would be k squared x squared. So then my next piece of information is, bear with me, so this question mark will be n factorial over 2 factorial times n minus 2 factorial. We've dealt with that before, haven't we? So that's not scary anymore. Times k squared x squared. What do I know that equals?
594.
Alright? So, that's my first piece of information, that's my second piece of information.
For the second term, we just wrote nkx equals negative 36x. How do you get just n if the term is n minus 1?
What's the first line of Pascal's triangle is always 1, the second one is always itself, yeah.
I was looking for like first of the like the 1 to the power.
Yeah. Well, yeah, that's kind of, you could write that formula again, but do this formula, but it would be 1 factorial over, but then you'd simplify and end up with just n, and you'd be like, oh yeah. So you could do the same thing. It's just a bit of a shortcut because I remembered that something 1 is always something. Yeah. Nice point to remember. So what can we do here then? Well, excuse my rubbing out rather than writing it, but that's an x and that's an x I can just get rid of, and that's the x squared and that's the x squared. Make sense? Because you don't need them. You don't need to know what x is.
Wait, we need that. Oh, that's for the 1.
Yeah.
Wait.
Shall we have a go at simplifying n factorial? See whether we can do that. So let's simplify n factorial over 2 factorial n minus, this is what we did yesterday by the way. So that would be n times n minus 1 times n minus 2 and so on forever, over 2 times n minus 2 times n minus 3 goes on forever. So we are left with, they cancel and then they would cancel and cancel. So we're left with n times n minus 1 over 2. And that would be times k squared, and that equals 594. So that would be my new number 2, my newly simplified. So what, I'm writing the 1s and 2s to give you a clue. What are we going to have to do? Two unknowns, 2 equations, simultaneous equations.
Oh my god.
No.
Mr. Potts, if you put this question on my test,
I'm not. This is Courtney. Don't blame me. I wouldn't have done these. The important bit, I guess, what for you is if the unknown is the power of n, you are going to have to use this formula, and you need to know how to simplify it and solve for n. Yeah, that's what we did. Done that a couple of times.
How come it's not n minus 2 and then just n minus 1?
Because this goes on forever. So as
No, like the bottom part.
Oh, she wasn't here yesterday.
no, so if you do a factorial, let's say it's 5 factorial. What is that? That's 5 times 4 times 3 times 2 times 1. Now if I make that n, that would be n, and then this would be n minus 1. This would be n minus 2, n minus 3, and then finally n minus 4. Alright? Now, if I change that a bit, so I've got a formula, so I've got 5 factorial over 3 factorial. If I still say that, well, that would be 5 times 4 times 3 times 2 times 1. This would be 3 times 2 times 1. But if I were to say that was n again, that would be n factorial. In terms of n, this would be n minus 2 factorial. Yeah, because 3 is 2 less than 5. So on this, it would become n times n minus 1 times n minus 2 times n minus 3 and so on. And this would start with n minus 2, and then 2 is n minus 3. It have to be one less, yeah? And then finally n minus 4. Now, because I've got top, they all cancel out. So I'm left with only that bit. Right? Now for this one, they go on forever. Both of them, top and bottom, go on forever. So they all cancel each other out. So we're left with only the bits that haven't been dealt with before. Right? Does that answer? Right. Simultaneous equations then, how are we going to go about solving these? Is it elimination?
Can I first, before you do that, times the 2 by the 5?
Yeah.
Yeah, you could do that if you want. So number 2 is then n times n minus 1 k squared equals is that right?
Yeah.
So what am I going to do? I'm going to take this one, it's the nice and simple one, and I'm going to rearrange it to make it either n equals or k equals, and I'm going to do substitution. Which one would you like to find, the n or the k? K, okay. So if I want to know what k is, I've got to get rid of the n, so I rearrange it to make n equals negative 36 over k. Now, that then is going to replace anywhere where there's an n.
Oh my gosh.
You pick the horrible one. So then we are going to end up with minus 36 over k times minus 36 over k minus 1 times k squared. And that is going to equal, and although that looks horrible, I can already see it's actually going to end up quite nicely.
Oh, great.
Because minus 36, I'm just going to write 36 squared for the moment, and that would be over
K squared.
k squared.
Where does this always mean?
And then this would be,
Because you substituted, you have two
Substitute.
equations and you use one.
So we made n equal negative 36 over k. So we put that into equation 2.
so this replaces the n's because I've got n equals. So I'm using substitution method of simultaneous equation. I think this question is beyond the level you need to be at, so, but it's good practice, it's not too. So minus 36 squared, got rid of the negative. Same here, look, that would be plus 36 over k. We have to multiply through by k squared. Alright? I think even the computer's complaining about this question. So what do we get? Times k squared gets rid of that one. So we've got 36 squared. And then we've got 36k squared over k gives me just 36k. And that equals 1188. I took a lot of shortcuts there. I did it in my head. Are you okay with what I've just
I
done?
don't understand how you got 36k from 36 over k times.
Okay, I'll do it in full. So I'm expanding the brackets. So I've got 36 squared, k squared over k squared
Yeah.
plus 36k squared over k. So I've expanded with that one as well. So then this k squared cancels that, so that leaves me just the 36k.
Why didn't you do it where the k?
And then the k squared cancels with this k squared, so it gives me just 36 squared.
Wait, why is it 36 and not like a bigger number? From like 36 times 36.
I've just written 36 squared. It will be a bigger number, won't it? don't want to write it, so I just left it as 36 squared. It will end up being a bigger number once I've finished it. You don't have to write them. You write numbers in any form you like. That's how, you know, as a mathematician, you need to learn what you are and aren't allowed to do. And so how do we solve that then? So minus 36 squared. So I've got 36k is 1188 minus 36 squared, and then divide through by 36, giving me k equals minus 36 squared all over 36, which you can stick in your calculator. Now we're hoping 36 squared is bigger than 118. -3, love it. Nice and simple. Maths is elegant. A lovely, elegant solution.
How'd you cancel those x's up there?
Which x's? There's no x's, they're k's.
I mean k's, yeah.
K squared divided by k leaves me with just k.
Wait, I have a question. When you
Let's just check Hardy's. Okay.
So
It's just
the K
cancelling
in the
fractions.
bracket,
Hey?
So like the k up there.
So I expanded this bracket. So I did that bit first
Okay,
to get that one.
Yes.
Then I've still got to do the expansion for the k squared.
Okay.
So I did that. So I ended up with,
But why is it only the top?
because when you multiply a fraction, you only multiply the top. That's where people make mistakes.
We didn't do the just now we did the bottom.
Right. Remember, there's a difference between writing an equivalent fraction and multiplying the fraction. So for instance, if I want an equivalent to a half, so I don't want more of it, I just want the same thing, I can multiply the top and bottom by the same thing and get 3/6. But I haven't done anything yet. But if I want 4 times a half, I need 4 halves. Therefore, I have times the top only. Right? That is a common mistake, by the way, is that.
So if you times
What? So if it's just if it's on this side, you times it by the top and the bottom, and if it's on this side, you only times it by the top.
No. What I want is that fraction multiplied by k squared. I don't want the same fraction.
Fraction against times.
Yes.
So it isn't a fraction. Okay, that makes sense.
Oh, true, yeah, because it's a fraction times a fraction.
so when the fraction
Okay, I
times a
didn't expect-
fraction, you do top.
Yeah, so,
Yeah. But when it's like a single number times.
yeah, I didn't spot that. So if I wanted a half times 3/8, you multiply tops and bottoms. I'm sure you've then done that before. If I did a half times 4, you've probably done over 1 and multiplied tops and bottoms again, yeah?
I never thought of it.
Can you scroll up just a little bit? A little bit more. Just a little bit more. There you go.
So we've got k. K is -3. Lovely, elegant -3.
N.
Pardon? Yeah, we haven't found n yet,
Point at the question.
but we just put.
And X.
No, then you can play
No,
it.
you don't have to find
We
it.
don't need to find that. X is part of the expansion. Yep.
Wait, how come we're dividing by 36 in the second last step?
Because I've got 36 k's. I want 1k.
Ah.
Yeah? 36k. So I've got k is -3. How do I find n? Well, how do you find the second variable in simultaneous equations?
You input the k in the formula.
Yeah, you just put it in. Now, which one do I use? Well, I'm going to go back up.
Wait, how
You can't tell me to scroll up one moment.
Why is K a -3 not a 3?
That's just how it
The
is.
calculator told me.
Because if that gives you a -1 on top, and you said the minus on top means it's a minus on bottom, then
No, I didn't.
you-
I said it's the same. A minus on top means the whole fraction is minus.
Why is that still 36 squared?
So what did you paste?
No. Because what we have is minus, like it was
I like this question.
36 plus 36k, yeah?
Yeah, but
How do I rearrange? I have to subtract 36 squared. Now I want to subtract the whole number. So it's like that. It's not minus 36 squared. So what's 36 squared? Calculate. 1296 over 36. So when I do 118 minus, I will get minus 108, and it's over 36, which gives me minus 3. Okay. Now we decided, if you just refer back, everyone, we did decide all the way up here, look, that k had to be negative, because here, look, in this one, n times k has to be minus 36. We know n has to be a positive integer, therefore we were expecting k to be negative. Now what's n?
It's minus 3 divided by, minus 36 divided by minus.
Minus 36 divided by minus 3, 12.
That's correct as well.
That's correct as well. So as we do always with simultaneous equations, I've solved k is negative 3, so I input it into whichever part I want, but I'm going to choose number 1, nk equals minus 36 was my first one, so that means n times minus 3 is negative 36, which makes n 12. Okay? Long, tough,
Fun.
good one, yeah. It's a lot of concentration. The maths in that is not amazingly hard, but it does test your understanding of what's going on, and it brings in those other things like simultaneous equations and not the assumption, but the knowledge that for that first bit, this one, the n, it was n and not n factorial. There's a lot to it. That would be a very challenging question in terms of challenging your understanding.
you should give it to us and then 100.
No.
Really?
Really?
Do you not give them any